Guys, welcome to my next video in mathematics. The video which I want to present, guys, sorry, I have not buttoned my buttons, is the video on now indices proper. I've already given you the video on the lesson plan you can use to teach indices. But this video now, I want to now give the details of indices by giving a few definitions here and there in this topic indices. And this one is specifically now for everybody. Remember, the first video on the lesson plan is for teachers because I don't think students require the lesson plan. That one for the teachers to look at maybe and improve where what I've done. Maybe you can have even modifications to suit your level of students. So this one is for, I think, everybody, because now I'm trying to go into details about indices because I'll give a few definitions and then, of course, see interesting things in the video. But I invite now everybody, but mostly the students of mathematics. But we are also saying even those who did mathematics a very long time ago and have forgotten are welcome to the video, guys. So welcome. Subscribe to the channel for more videos of this nature. As I said earlier in the other video, this video is intended for students who have mathematics as a compulsory subject. All who have done it before, but they did it a long time, and they feel they have forgotten mathematics in indices. How do you use this video? You will not gain much by just watching this video. Have a pencil and paper ready to work through the questions before reading the solutions. Read each question carefully before attempting it. It is important that you try hard to complete the questions on your own, rather than refer to the solutions as soon as you are stuck. Because, I've given questions, sample questions and answers. Please don't look at the answer and then you do the question. Do the question and maybe give somebody the work you have done to mark for you as you look at the answers. If you have any difficulties with the questions, don't look at the answers. Go back and study the textbooks in more details. I'll be giving a video on the textbooks. So guys, don't forget to always enter this channel or tune in to this channel to see the textbooks which you are required to refer to in this topic. I have got the textbooks which are international books, and I have also textbooks which are reference books in the Kenyan context. So, welcome to the indices, where my first job is to define what is an index. An index, and in some books, an index is known as an exponent, is a mathematical notation indicating the number of times a number. This number is known as a base, is multiplied by itself. So the number you multiply the base by itself. So the index is that number which is known as the base It is typically written as a small number to the right, to the upper right of the base number. For example, in the expression 2 cubed, some people will say 2 cubed, others will say 2 to the power of 3. The number 2 is the base and the 3 is the index or exponent. It indicates that 2 is to be multiplied by itself 3 times. So the 3 or the index shows the number of times you are going to multiply the base 2. And therefore, 2 cubed will be 2 times 2 times 2. That is 3 times. And this equals to 8. We now look at the terms which you encounter in indices and their meanings. So we have the root. What is a root? What is a radicand? What is an index? What is a square root? And what is a reciprocal? All these terms will be found in this topic known as indices. So may I start by defining the word root. A root of a number A is another number B, which when raised to a certain power n equals A. Remember, A, B, and n are general numbers. This is often written as, you can see what is written there, but if I read it, it is the nth root of A equals B, meaning B raised to n equals A. All right? And the common types of roots include the square root and the cube root. Although we have other roots like fourth root, fifth root, sixth root, and even many more, whatever number you want to have. But the most common ones are the square root and the cube root. The next term you find in this topic is the radicand. And the radicand is the number under the radical sign in a root expression. For example, in the expression cube root 27, the number 27 is the radicand. It is the quantity for which the root is being taken. Index. Index, or sometimes you call it the degree of a root, indicates which root is being taken. It is the small number written just outside and to the upper left of the radical sign. For instance, or for example, in the fourth root of 81, the index 4, indicating the fourth root of 81. If no index is written, it is assumed to be 2, which just simply signifies a square root. So if the radical sign does not have any small number just outside and to the upper left of the radical sign, then that one is automatically square root. So square root, you don't need to put 2 at that position. Square root. The square root of a number is a value b such that a squared equals b. So that the number you are squaring, to get that number, the number you get, this number you are squaring is the one which is known as the square root. So it is denoted as, you see the radical sign and a, or red, square root of a. For example, square root of 16 equals 4, because 4 times 4 equals 4 squared, which is equal to 16. The square root is the most commonly used root. Reciprocal. This is a fraction whose numerator is always 1. Remember, a fraction is made up of 2 parts. The first part is known as, the upper part is known as numerator, and the one below the line is known as the denominator. That line in mathematics is known as vinculum. So the number above the vinculum, spelled V-I-N-C-U-L-U-M, vinculum, that horizontal line which divides a fraction. The number which is above is the numerator, and the number below is the denominator. So for a reciprocal, the numerator is always 1. For example, the reciprocal of 5 is 1. Put the vinculum, and then you make 5 the denominator. If a is a fraction, m over n, then its reciprocal is n over m. And here, I'm trying to show you how you get it. So, we want to get the reciprocal of m over n. So the numerator is 1 and the denominator is m over n. And that is what we have written there in this bracket, which is trying to explain. So 1 over m over n equals 1 over m divided by n over 1. So this is the same as 1 over m over n over 1, which now becomes 1 over m times n over 1. So when you divide with fractions, you change the sign to multiplication, and then you invert the divisor, which is equal to, you multiply the numerator by the numerator, which is 1 times n, and then denominator by denominator, which is m times 1, which equals n over m. Reciprocals are used in division and multiplication operations, particularly when solving equations or simplifying expressions. In more general terms, the index or exponent n in the expression a raised to n tells us to multiply base a by itself n times. Exponents can also be fractions or negative numbers representing roots and reciprocal values, respectively. So here is an explanation of exponents when they are fractions or negative numbers. Indices can also be fractions or negative numbers. Fractional indices represent roots, while negative indices represent reciprocal values. Let's now go to fractional indices. So, let's now tackle fractional indices. Fractional indices represent roots. The numerator of the fraction indicates the power, while the denominator indicates the root. The numerator of the fraction indicates the power, while the denominator indicates the root. For example, a raised to a half represents the square root of a, written as the radical sign and a under it. A raised to 1 over 3 represents the cube root of a, written as the radical sign with the radicand and the small 3 outside. In general, a raised to m over n means nth root of a raised to the power of m, written as radical sign radicand a raised to m over n, or equivalently, the square root of a, the nth root of a, raised to m. Nth root of a raised to m. Examples 8 raised to 1/3 equals the cube root of 8, which is equal to 2, because 2 times 2 times 2 is equal to 2 cubed, which is equal to 8. 27 raised to 2 over 3 equals 27 raised to 1/3 brackets squared, and this is equal to the cube root of 27 squared, which is equal to 3 squared, and this simplifies to 9. Negative indices. Negative exponents or indices represent reciprocal values. Specifically, a raised to negative n means the reciprocal of a raised to the positive power n. For example, a raised to negative 1 is the reciprocal of a, written as 1 over a. Because we say for reciprocal, the numerator is always 1. A raised to negative 2 is the reciprocal of a squared, written as 1 over a squared. For example, 2 raised to negative 3 equals 1 over 2 cubed, which is equal to 1 over 8. And 5 raised to negative 2 equals 1 over 5 squared, which is equal to 1 over 25. Combining both concepts, that is fractional and negative indices. When you combine both fractional and negative indices, you can understand and manipulate expressions more flexibly. For instance, 4 raised to negative 1/2 is the reciprocal of the square root of 4, which is 1 over the square root of 4, which is equal to 1/2. 16 raised to negative 3 over 4 is the reciprocal of the fourth root of 16 raised to the third power, which is 1 over the fourth root of 16 cubed, which is the same as 1 over 2 cubed, which is 1 over 8, because 2 times 2 times 2 times 2 times 2 is 16. Understanding these rules allows you to simplify and solve a wide range of mathematical expressions involving exponents. So, I repeat, this work, or I acknowledge the work, because it is like a team effort. Too many people inspired me to come with this video, and I thank them with all my heart. I would also thank my family members for their support, encouragement, patience, and tolerance during my long hours of typing, even during the night. The content of this video in Microsoft PowerPoint 2010. I'm grateful to ChatGPT for assisting me to polish my video to be of this standard. Every effort has been made, of course. to contact or reach out to the copyright holders of anything which might have been included in this video. But if we have not reached you, wherever you are, we will make necessary arrangements for this opportunity. So I would be pleased to make amends the earliest possible opportunity. This video can only be reproduced for educational purposes only. So thank you guys for watching the video. Share this video with as many people as possible. Don't forget to subscribe to this channel, guys, to support me so that I bring more videos of this nature. Please, if you have got a comment on what we can do to improve this video or this series of videos in mathematics, you are warmly welcome to do that. Otherwise, for now, bye-bye, and see you on the next video on indices. Bye, guys.